Hello student, welcome to another video. In this video we will see how to find out particular integral when the right hand side function of x is of the form either sine of ax plus b or cos of ax plus b. So remember, I am again telling, we will use this method only when our right hand side is of the form like this and this, where a and b are constant. So in that case, particular integral is of the form this, sine of ax plus b by f of d. Next, our objective is to check whether f of d, that is function of d, can be written as function of d square only or function of d square and d only. Obviously f of d can be written as either function of d or function of d square or function of d square comma d. Okay. Now, if f of d is phi of d square, in that case particular integral is f of d by sine of ax plus b by phi of d square. So I can write this is as another sine of ax plus b by phi of d square, which is our particular integral. What we will do, we replace d square with minus a square. So what we will do, we replace d square with minus a square. Remember, minus is 8, provided phi of minus a square is not equals to 0. If this is not equals, this is your particular integral. So in general, not possible that f of d is always, I can write function of d square only. So it may be of the form phi of d square and d. In that case, if f of d is phi of d square comma d, then particular integral is sine of ax plus b by phi of d square comma d. In that case, again, what you will do, you replace d square with minus a square and d remains as it is. What will you do? You replace d square with minus a square and d remain as it is. Then look, if you replace d square with minus a square, then this become a function of d only. This, okay, this becomes sine of ax plus b by function of d. What will you do next step? You multiply up and down with conjugate of this function, g bar d. G bar d is what? G bar d is conjugate of this function. When I will explain an example, you will understand the matter very clearly then. So I replace up and down with g bar d, then this will become again a function of d square. Obviously, if you multiply conjugate with this, then this will become square. So again, you replace d square with minus a square, provided psi of minus a square not equals to 0. I hope you understand up to this. Now, what if possible if this is equals to 0 or here this equals to 0? In this case, how will you go ahead? So suppose if this equals to 0 or this equals to 0, for the sake of argument we consider let phi of minus a square equals to 0. Then how will you proceed? Then our formula is particular integral equals to x comes outside. So our particular form integral is sine of ax plus b by f of d, where you found f of d is phi of d square and you replace d square with minus a square, you will get phi of minus a square equals to 0. In that case, after this step you write x comes outside, sine of ax plus b by f dash d. Okay, one x come outside, this will be derivative of fd. Now check again, fd can be written as phi of d square or this, and the previous method as well, so as it is. You will get understand when I explain an example. Suppose This is one of the differential equation. You have to solve this. So your f of d is this. Okay, I hope you understand how to find out the CF. So two different values, so your CF is this, are arbitrary constant. Okay, now your particular integral is sine of x by d square plus d minus 2d. Here f of d is of the form d square and d, because here d square is also present, d is also present. So what you will do by the rule, you replace d square with minus a square. Your a is 1. Okay, so a is 1, so d square is replaced with minus 1 square. Next line, sine of ax by minus 1 square plus d minus 2. So this will become sine x by d minus 3. So this is your g of d. So now what you will do, my conjugate of g of d is d plus 3. So I multiply d plus 3 with up and down. Then this downside term become d square minus 9. I hope you understand this one. Then again you replace d square with minus a square. Here a is 1, so minus 1. So become d plus 3 sin x by minus 10, which eventually becomes d of sin x plus 3 sin x. d of sin x is nothing but cos x plus 3 sin x by minus 10. Therefore your general solution is CF plus PI. Come to another example, this one. Now again you will get e to the power mx be the trivial solution of this. Therefore m is plus minus ia, that is alpha plus minus I beta form, where alpha is 0. So your CF is e to the power 0 into x into c1 cos ax plus c2 sin ax. So this is your CF. Now come to particular integral, sine of ax by d square plus a square. Here f of d is phi of d square. So if you replace d square with minus a square, you will get this become 0. So I cannot write that. In that case, what will I do? I write x outside, sine of x by derivative of this. So your f of d is d square plus a square. So f dash of d is 2d. So I write 2d. So again x by 2 comes out 1 by d sin x. You know this is integration. I will get minus x by 2a cos ax. Therefore my general solution is y c1 cos x plus c2 sin x minus this. This is one technique. There exists also another technique. For that we have to know the de Moivre's theorem, where e to the power ix I can write cos ax plus I sin ax, where real part of e power ix is cos x and imaginary part of e power ix is sin ax. Now according to the problem, our particular integral is this part, which is nothing but imaginary part of e power ix by this. That is, whatever value I get from here, I have to take the imaginary part, which is equivalent to this. Now what will I do? E power ix by d square. This is the previous method way, that is e to the power x by f of d, where a is ia here. So what will I do? I replace d with ia. If I put here, then this will become 0. I hope you understand this one. Next, if this by the previous method x come outside, I have to take f dash d, which is nothing but 2d into the e to the power ix. Then again replace d with ia. I put it here, eventually become this. Now what I will do? I multiply up and down with I. So general way is do not write I on the downside, or do not keep in that way. So multiply up and down with I, this become minus 2a. So eventually becomes this one. Again you write, split the e to the power ix into this form. You multiply, you will get this, and then you again multiply, you will get this is your real part, this is your imaginary part. Remember, minus is also included in the imaginary part. Therefore imaginary part of this is equals to minus x by 2a cos ax, which is similar to the previous one. I hope you understand.